I want to talk about the graph domain and range of a logarithmic function. So suppose that we have f of x equals negative log base 2 of x minus 2. So the first thing that I want to do is I want to try to figure out what we can graph that's going to help us, because it's going to be hard to just graph this function all by itself, but it might be easier if we can figure out some other graphs that we can look at. So the base of this function is going to be log base 2 of x. So let's consider that. So let's consider g of x, which is log base 2 of x. Now, this minus sign out front is going to make all of my outputs negative. So it's going to be a reflection over the line y equals 0. So it's going to be down instead of up. So if you think about like a parabola, if it has a negative out front, then it opens down instead of opening up, and the same thing is going to happen here. It's going to be kind of down instead of up. So it's going to be reflected over the x-axis because it's negative. So that's going to be this part. And then what's going to happen with the minus 2? Well, minus 2 is just going to shift it down 2 at the very end. So let's go ahead and graph log base 2 of x. So remember that log is the inverse function of the exponential function. So if we take a look at y equals 2 to the x, let's just list some of our inputs and outputs. We have the 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4, 2 to the third is 8. Okay, so our logarithmic function is going to be the inverse of that. So it's going to be 1, 2, 4, 8. I'm just copying the y column, and then 0, 1, 2, 3. So let's go ahead and graph this function. We also know that it's going to have an asymptote at x equals 0. So let's try to draw this asymptote. Alright, so drawing in this asymptote here. Alright. Okay, so that's the asymptote. And then we have 1, 0, 2, 1, 4, 2, and 1, 2, 3, 4, 5, 6, 7, 8, 3. Okay, so we're going like this, and then we're going down toward the asymptote. So now we want to reflect this over the x-axis. So it's going to get flipped upside down. And then, so that's going to look something like this, right? But then it's also going to get moved down 2. So let's go down 2 from here. Now we're going to flip this over, so it would be here, but then we're going to go down 2 more. Here we're going to flip this over, so it's going to be negative 2, but then we're going to go down 2 more than that. And then here we're going to flip this over, so it would be negative 3, and then we're going to go down 2 more than that. So then the final function is going to be like this. And that is how we graph f of x equals negative log base 2 of x minus 2. Now I want to do one more example, and I want to show you how to do it a slightly different way. So get rid of all of this stuff, and let's do one more example. So what if we had f of x equals log base 3 of negative x and then plus 3. Okay, so the basic function that I'm looking at here is log base 3 of x, but I don't even want to worry about that this time. I'm not going to do this one based on transformations, I'm just going to do it based on plotting points. So if I want to do this based on just plotting points, what I need to remember is that when I plug in points here, the logarithm is going to come out to be an even number if I can plug in a multiple of 3. So anytime I can plug in a multiple of 3, the logarithm will come out to be even. Because for example, log base 3 of 3 equals 1. Log base 3 of 9 equals 2. And again, you can think about changing into your exponential function. So 3 squared equals 9, right, and so on. And log base 3 of 1 is equal to 0, right, because 3 to the 0 power equals 1. So knowing these, I can use that to help me make my table of values, and I can use these values. So the thing is though that here I have a negative x, right? So when I put in my x's, I actually need to put in the negative of whatever the input needs to be in order to make it go into the logarithm positive. So if I let x equal, let's do the 1 first, let x equal negative 1, then a negative 1 is going to be a positive 1, and log base 3 of 1 is 0, plus 3 is 3. So then what I can do next is put in this one. So in order to get an input in the logarithm of 3, I need to put in negative 3. So I'm going to put in negative 3. It's going to be log base 3 of 3, which is 1, plus 3 is 4. And then the next one I'm going to do is putting in 9, so I'm going to put in a negative 9 here. That's going to be a positive 9 in the logarithm. Log base 3 of 9 is 2, plus 3 is 5. So this should give me a place to start here. So negative 1 is 3, negative 3 is 4, and negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9 is 5. And it looks like we're going right toward this asymptote at 0 still. And there was no horizontal shift, so it should be still going toward that 0 asymptote. So this is what the graph would look like. It would have a vertical asymptote at 0. So the vertical asymptote would be x equals 0. And this should make sense as a graph because it has a negative x, which means it's going to be reflected over the y-axis. So it's, instead of being over here, it's over here. And then it has a plus 3, so it's going up 3. So normally it would be going kind of down here, but it's gone up 3. So this graph makes sense based on what I know, but it's kind of a different method for getting there. So those are two ways of how you can find, now we need to find, the domain and range of these functions. So let's make sure that we find the domain and range. So the domain is all the possible inputs. So in this case, there's no function over here. So all the possible inputs are going to be from negative infinity all the way to 0. So from negative infinity to 0 is the domain. And an open circle here or a parentheses here because we can't ever actually get to that asymptote. And then the range, well, this is going to keep going down forever, and this is going to keep going up forever even though it's slow. So it's going to be from negative infinity to positive infinity. And so that is how you find the graph, domain, and range of a logarithmic function.